Hello everyone, my name is Ajay and in this section we are going to discuss about Azure Global Traffic Manager. This is the DNS-based load balancer basically, and it is meant to perform multiple tasks like performance, customize content, disaster recovery, and maintenance. So you can assume a situation like that. You might have the multiple resources, those are hosted in multiple data center or maybe multiple geographic location. It can be on cloud, it can be on-prem, and your users, they are coming from internet all over the place. And then you have an intercepted device, which we call it a global traffic manager, which is going to return the DNS value that can be based on the performance. So when I refer to the performance, it is going to be the latency between your end user versus your resources. You might have a situation where you want to serve all these users some specific content, maybe based on the language, maybe based on the geography. And then you can have the disaster recovery mechanism as well. So if you have these kind of application hosted all over the place, you can divert your traffic considering one data center or one cloud location is going to be the primary versus others are going to be the secondary. And maintenance, that is a key feature. When you are performing the maintenance, you don't need to shut down your application. However, you can tweak it and redirect your traffic to other locations. So let's get started. You can compare your global traffic manager with other vendors like F5. In F5 word, we call it GTM. And if you go for other load balancing mechanism, you can call it GSLV. It is very, very similar and all works based on the DNS request resolution. So Azure Traffic Manager is a DNS-based traffic load balancer, which allow you to distribute your traffic to your public-facing endpoints across global Azure regions. An endpoint can be any internet-facing IP address hosted in Azure or outside of Azure. What it means, you might have the virtual data centers environment, so you can call it your application might be hosted on somewhere on the Azure cloud, and same time you can have some portion which is hosted on-prem, so you can call it as a hybrid infrastructure. Let's take an example and understand how this is going to work. So here we can see there's a user with a browser, and when I'm going to do some website surfing or application browsing, so for example here I'm opening www.technettalk.in, and the request goes to your LDNS, and I'm using the traffic manager. A traffic manager basically provides you some sort of URL which is going to be trafficmanager.net. So I need to do some sort of CNAME record on the DNS. So this technettalk.in is redirected to traffic manager. And once your request is intercepted by the traffic manager, this is a global resource, doesn't matter where you host it. So request comes to the traffic manager, it will be intercepted, and there are going to be the routing rule basically, how this traffic manager is going to redirect your request to the end public host. Once it decide where it is supposed to go, it is going to return that IP value to this DNS request, which is coming from user. And once user receives, in this example, it is receiving the Europe IP address. Once it receives the Europe IP address, this browser can directly connect to your resources, which is hosted on Europe. There are many offering comes from Azure when it comes to the load balancer. So we should be very, very sure what we are selecting and what is appropriate load balancing mechanism for our application. So to start with, this is a chart and which asks you the information which you can follow. If your application is a web application based on HTTP and HTTPS, if your answer is yes, you can go for the next criteria, which is going to be and is it internet facing or not. However, we will focus here on GTM portion, so let's follow this way. Is this application a web-based application? If your answer is no, is this a internet facing? If your answer is no, you can simply go for Azure Load Balancer, which gives you basically the IP based 5-tuple load balancing mechanism. If your answer is yes, my application is internet facing and it is deployed across global regions, you can go for a traffic manager, and you can also go for a combination of traffic manager plus load balancer. It needs a endpoints to be configured, and those endpoints can be behind your load balancer. They can be standalone, and which we are going to take a look when we do the labs and explain rest of the theory. There are multiple traffic routing methods available with the Azure Traffic Manager. One of them is going to be the priority, and you can always put the highest priority or that particular node where you want to redirect all the traffic. You can also put some of the priority for your failover nodes as well. Then you are going to have the weighted, and weighted method, it is going to return the best performing endpoint. And here you need to put some weight value, and highest weight will be preferred. Then you have the performance. Performance is going to be based on the latency between your host or client and endpoint. And keep in mind, when we are talking about this latency, it is based on LDNS IP address from where the DNS query is sourced from. Then you have the geographic. In this geographic, you can basically associate your endpoint with those particular geographic location. And if you remember, I have mentioned one of the feature which is going to be providing the specific content for a specific geography. That is something as what we can achieve from while going for the geographic method. Then you have the multi-value, and multi-value is basically allows you to get the multiple healthy endpoint in one DNS query. Subnets, you also have flexibility to map your end user IP subnets to specific endpoints. So whenever the request comes from those particular IP address, it is going to return you the value for that particular endpoint. Let's now understand how we can improve website response while using Azure Traffic Manager. And I'm going to choose a routing method which is going to be the performance, and performance means the traffic to the location that is closest to you. As I mentioned earlier, it is going to be based on the latency between your LDNS and endpoint. So here in this example, you can see I have a user and there's a browser, and this browser is going to do some DNS query from the LDNS. And once this query reaches to the traffic manager will keep track of the source IP. This is not just a source IP, it's going to be the full subnet range, and that is going to be for this LDNS. However, there's a one RFC. If your DNS infrastructure is going to get you the ECS value, it means it is going to be the user public IP address plus your LDNS. That is going to be the more accurate way to locate this infrastructure. Then you are going to keep track on the source IP address, and for example, location A, which is going to be the public endpoint. Then you have a location B, location C. So this is the latency between the source subnet to endpoint. And since the option we have chosen is a performance, it is going to prefer lowest latency, which is going to be the 100 ms. In this case, all the requests which is intercepted by this traffic manager, they will be going to location A. It's time to take a look on the traffic manager deployment. So on the Azure portal, you can basically locate the resource which is going to be the load balancing traffic manager. So you can put those keywords and you will land here, especially on the traffic manager. And now we see there's no traffic manager configured since we never created one. You can create it from traffic manager profile from here, or maybe you can create it from here. So both the options are with you. So let's hit the create button and see options it is going to ask for. Once you hit the create button, these many options are going to be in front of you. So first thing, it is going to ask for a name, and this is basically a URL name which will be allocated to your traffic manager, and the domain name ends with trafficmanager.net. This name should be unique. I just wanted to show you that I have given the test and it is already taken. So it should be unique. This is globally unique DNS entry. Then you need to mention your routing method. By default, it is going to be the performance. I just left as it is. And the reason behind I want to do my labs based on this method. And maybe in the upcoming videos, I will go for rest of the options as well. This is a subscription. You need to choose your resource group, and resource group location is East US. As I mentioned earlier, this is going to be the global resource. No matter where you create it, it is going to work for you. Now it's time to hit the create button. So I'm going to make this as a unique entry. So I'm going to change the name from test to test-aj, and that works. There's no conflict. Now we can proceed with the create button. Right hand side on the top, you can see the request has been submitted for the deployment. It might take 1 or 2 minutes to get the resource ready. My traffic manager resource is ready with the name test-aj and the status is enabled. Routing method is going to be the performance, and the resources group is going to be the client underscore group. Now, once your traffic manager profile is provisioned, you can see the status which is enabled. Resource group is going to be the client underscore group. Monitoring status is inactive, and the reason behind we haven't added any of the endpoint here. This is going to be the DNS name you can access from, and you need to create a CNAME if you want to go for the customized domain. And these are going to be the options which we need to focus going forward. Now let's explore the options which comes under your profile. So first is going to be the configuration. We all know it that the routing method we have chosen is going to be the performance, and you can see there's a DNS TTL value, and that is very important as well. So it is basically going to enforce the policy how long this DNS value will be cached. There are going to be the resolver, and if your website is so dynamic and you keep making the changes, then it should be a very short TTL value which we need to put, and it is a number of seconds this entry is going to be valid. And once this time expires, it is going to do another lookup. So this is very important. Second thing is going to be your monitoring setting, how you're going to monitor your endpoints. So here, if I'm using HTTP, then this is going to be the port 80, which we need to pull, and this is going to be slash directory. It means it is going to pull index.html here, the default directory basically. Then you have the failover settings. Probing interval is going to be the 30 seconds. Number of failures it can tolerate it, 3. And probe timeout is going to be the 10 seconds. I will leave it default because I'm going to use endpoints. Those are going to be HTTP. Now it's time to take a look another tab which is going to be the endpoints. Since we are going to offer some sort of the application, so we need to add the endpoints here. As of now, I don't see any result. Reason behind I have not added any of the endpoints, There is an add button. You can click here and then you can add your endpoints. And when you add the endpoints, it is going to ask you the type of endpoint. So you see the option Azure endpoints. That is going to be the default one. Any of the services which is hosted on the Azure cloud, you can choose it from here. Second, if you have some services which is hosted outside of the Azure cloud, those are going to be the external endpoints. And then you have the nested endpoint profile. So you might have some complex scenario where you want to do some sort of the failover, etc. Then we use a nested endpoints, and this nested endpoint I'm going to cover later on this video. Then it comes to targeted resource type. By default, it is going to be the cloud services, but when you expand it, it is going to give you more options. Let's take a look on that. So let's try to configure Azure endpoints to start with. So my type is going to be the Azure endpoint. You can enable endpoints. You need to put some sort of the name here, and then it is going to give you these options. The first option is going to be the cloud services. This is depreciated one, and those services you can configure on app services. So app services, this is a PaaS services. App service slot is also the app services, but you can do your staging environment created, which you can use as a service slot. Then you have the public IP addresses. So services what you create on Azure, maybe simply to start with, if you have a VM where you're running the IaaS, it is going to have the public IP address, which will get listed here. Now let's try to understand, as we know, there's something called web app services on Azure. And there's another service which is called Web App Service Slot. So in service slot, what exactly is happening? You might have two environments. One is going to be the production, and the production website is production.website.com. Similarly, you can create your staging environment as well. So staging.website.com. So all the traffic, it should come here. And while your testing is completed on staging, you can do the swap also. That means all the traffic will be redirected here. So you can have two environments created instead of creating a new web app. Let's go back to the configuration and expand the protocol field. You see there are three options coming. However, I'm going to use HTTP because I'm going to run the server on port 80. You have an option for 443 and TCP. For the lab point of view, I have created two VMs running with Apache services. One is going to be the UK web, second is going to be the US web. So I want to basically host my web services in two different regions. So you can see this is hosted in North Europe and this is hosted in East US. These are going to be the Linux machines and these are going to be the public IP addresses allocated. Now it's time to add and host here into the profile. So I'm going to choose, since these are the services hosted on Azure, so I'm going to choose Azure endpoint. I just named it as a UK web and then enable the endpoints, and target is going to be the public IP address. And the moment you choose a public IP address, it is going to list down all the IP addresses those are publicly available on your Azure. So I'm going to choose UK web IP, which I want to configure under this endpoint. However, see there's one error which is coming here. No DNS name is configured. So let's fix it. So you need to select your VM where you want to configure the DNS. When I go to the overview of that virtual machine, you can see DNS name is not configured. So what I need to do, I simply need to click on this not configured. It takes me to the configuration tab. And here you see this is the IP address and this is going to be the domain name. You need to choose a DNS name. So I'm going to put the same name as it is, UK web, and then the DNS FQDN becomes ukweb.northeurope.cloudapp.azure.com. Similarly, I'm going to do it for US web as well. Let's now go back and try to add those endpoints. So I'm into the same field again. I have chosen it's going to be the endpoint type. name is going to be the UK web, and target is going to be the public IP address. Now I see I have fixed a DNS entry for these two VMs. So now these are listed and can be associated as an endpoint to Traffic Manager. So I'm going to choose UK web here and click add. The moment you add these two endpoints here, you can see the status is enabled. However, for monitoring purpose, it is just checking the endpoint. And once these endpoints are pulled properly, the status is going to become online. Type is endpoints and the location is North Europe and East US. Now there's one more option, traffic view. If you really want to see your latency information, volume, location, etc., you can enable the traffic views, and it will not give you the information immediately. It need at least 24 hours to populate the information based on the connection being requested, what is the latency, etc., etc. Let's try to browse these endpoints directly. So my first endpoint is UK web north Europe .cloudapp.azure.com, and when I try to connect on port 80, I can see this is the default page which pops up. Similarly, the second endpoint is usweb.eastus.cloudapp.azure.com, and we are successfully able to connect both the URLs. Now we will try to browse from a URL which is associated with the traffic manager, which is going to be the test-azure.trafficmanager.net. And we see the request was intercepted by traffic manager and that is being redirected to UK Web Connect. That means while doing the traffic routing, my latency from my machine to this endpoint seems to be appropriate for this redirection. So there were two IP addresses basically allocated to these two VMs. Let's try to test it manually whether it is going to the right direction or the wrong direction. So when I ping my first IP address, which is 239, and that is UK web, it gives me the average latency of 143 ms. Similarly, when I ping my resources, which is hosted in East US, I get the latency of 208 ms. While choosing the performance, it is based on the latency. So lower latency should be preferred. So technically that is exactly what we see. All my traffic from my machine, it is supposed to go to this lower latency endpoint, which is going to be your UK Web Connect. Another thing, we need to create the CNAME. I host my domain on Azure Public DNS. So I'm simply going to create one entry. So I'm going to add a record set. The name is going to be www, and that is for technet.in, and the CNAME is going to be, I need to put the alias, which is going to be test-aj.trafficmanager.net. So now once you add this record, and if you do the NS lookup for your customized domain, which is going to be the technet.in, you can see it is returning alias entry, and that is what we need. Now it's time to test the website from the customized domain, that is, which is going to be www.technet.in. And when I browse it, you can see it is connecting me to the UK Web Connect, and that was desired result when we were browsing directly from Traffic Manager profile. So this DNS redirection works. As I promised, we are going to discuss the nested traffic profiles now. So each traffic manager profile specifies a single traffic routing method, and that's what we have seen while creating the first traffic manager profile. We have chosen a routing method which was the performance. And to support complex application, traffic manager allows traffic manager profile to be combined or nested, allowing the benefit of more than one traffic routing method to be used by a single application. So here, this was a similar example what we have done lab so far. I had created a traffic manager profile, and you can have multiple endpoints located to these three different regions. And here, the method was performance, which we use. Now, there can be a scenario, I leave West US as it is, East Asia as it is, and all the request which was getting redirected to West Europe, I'm going to put another traffic manager profile. And here I can host two endpoints. One is going to be the production, one is going to be the staging on trial. And now I want to play with another traffic routing rule, which is going to be the wait. So all the requests, those were supposed to go to West Europe. Now if I set a wait 99 here, it means all the requests goes to productions and some requests goes to your staging server as well. You can also put some sort of rule here when this child profile is going to be active versus when the failover should happen. So here you see the number of nodes are 2. You can define when it should be active. Maybe you want to put the threshold 2, or maybe you want to say when one host at least goes down, let's deactivate this profile and redirect traffic to rest of the zones. So there can be complex scenarios where this is very useful. And going forward, you are going to see how you are going to create nested profile and how it works. For testing the nested profile, I'm going to create another virtual machine which is going to be in North Europe, and we will assume on this machine I'm going to put something a staging application. So this machine is up, and then we need to create another traffic profile manager, and I named it as a nested UK, and you see it is inactive. I have not added any endpoints here, and the DNS name is going to be the nesteduk.trafficmanager.net. Under nested profile, you need to add the endpoints. So I'm going to add points, which is going to be the public IP address for the VM what we created. So you can see the IP was 40.113.21.250, and I'm going to put a wait 99. It means all the traffic should go here. Now you can see under the new traffic manager profile, I have added the newly created endpoint and the old profile or old endpoint as well. Now I'm going to put the wait value 99 for the new one, staging, and one for the production one. So I'm expecting all the traffic will go to the newly added endpoints. And when you test it from the traffic manager URL, and that's exactly what we see here. All my traffic goes through test nested app, and that is the expected behavior. And now you need to add that nested profile in original or the primary profile what we created. So the primary profile was test-Azure. Now instead of calling those Azure endpoints, I'm going to call the nested endpoints, and nested endpoint, you need to mention some name. I'm going to give it a test, and then you need to add the targeted resource, and we see this is going to be your newly created traffic manager profile. Is going to be the location, North Europe, and here you mention minimum child endpoints. It is basically defining the threshold. Minimum 2 should be available to keep this as active, and then you can add it. Now we see under the main profile there is a US web endpoint monitoring status is online, and then there is a nested traffic manager profile and monitoring status is online. Now if you test the website while opening the www.technet.in, it is redirecting all the traffic which was going to be the UK web. It is going to the newly deployed app server, and that is the expected behavior. Now I'm going to shut down one of the newly deployed app, and let's see how this behaves. So you can see under the nested profile, this is a nested app, and you can see the monitoring status is down. What it means, I had shut down this application server. However, UK web is still up, US web is still up,
Since we have mentioned the threshold 2, at least 2 endpoints should be on to make the child profile active. That is not going to fulfill the condition. Hence, my nested profile is degraded. And now, once it is degraded, all the traffic is expected to move to US. And when you test this web again from the browser, you can see the same results. All the traffic is going to hit the US Web Connect now. Thank you for watching, and I will see you in the next video.